2-4, solving for a variable. When we're solving for a specific variable, we have equations that have multiple variables, sometimes distributions, sometimes exponents. And our whole idea is to get a specific variable by itself. So if we look at some examples here, for 1, we have b is equal to a times x, and we want to get x by itself. So I'm just going to rewrite this. B is equal to a times x, and we're getting x by itself. So right now, that a and that x are being multiplied, so we're going to divide each side by a to get x by itself now. So x is equal to b divided by a, or b over a. For 2, they give us b is equal to x plus a, and we're getting x by itself. So we're going to move that a over to the opposite side. Remember, inverse operations are opposite operations. We're going to subtract a from both sides, and we're going to be left with x is equal to b minus a. For 3, they give us c is equal to a times x minus b, and we're getting x by itself. So first we want to move that b over. The whole idea is to get the term or terms that are attached to x by itself first, and then undo any division or multiplication that's happening. So that b we're moving over first, the sign in front of it is subtraction. We're going to add it to both sides, and we're going to be left with c plus b is equal to a times x. Again, we're getting x by itself. Right now it's being multiplied by that a, so we're going to divide each side by a to get that x is equal to c plus b all over a. For 4, they give us s is equal to a plus b plus c, and we are getting c by itself. So first, undo anything that's on the same side with c. So we can move that a over. We're going to do opposite operations. So we're going to subtract it from each side. It's going to cancel out on the right side. We're going to be left with s minus a is equal to b plus c. That b is on the same side as c, so we're going to subtract it from each side, and we're going to be left with c is equal to s minus a minus b. All right, so for 5, they give us a is equal to x over b squared, and we're getting x by itself. So from here, if we want to rewrite this, we can. We have a is equal to x over b squared. We want to get x by itself. Right now it's being divided by b squared, so we're going to do the opposite of that division, and we're going to multiply each side by b squared. So on that right side, they cancel out. You're going to only be left with x on that side, and then you have a times b squared, which is just ab squared on the other side. So x is equal to ab squared. For 6, they give us c is equal to m times v squared all over r. And we're going to get r by itself. So again, if we want to rewrite this so we have a little bit more room to work with, we have c is equal to m times v squared over r. So we want to get r by itself. Right now it's being divided by, or divided with, the mv squared. So our first idea here is to get rid of that division, so we were going to multiply each side by that r. From there, you then have c times r is equal to m times v squared. Again, your whole idea is to get r by itself. Right now it's being multiplied by that c, so now just reverse that and divide each side by c to get r is equal to mv squared over c. I'm just going to move back up here so that way I have a little bit more room. So for 7, they give us v is equal to b times h, and we're getting b by itself. So again, that b is being multiplied by h, so we're going to divide each side by h and get that b is equal to v divided by h. For 8, they give us d is equal to r times t, and we're getting r by itself. So we're going to divide each side by t to get r is equal to d divided by t. For 9, we have e is equal to mc squared. We're getting m by itself. So m is being multiplied by c squared, so divide each side by c squared. And we have m is equal to e over c squared. For 10, we have f is equal to mv squared over r. We're getting r by itself. So again, I'm going to rewrite this just so I have a little bit more room. I'm going to multiply each side by r. That's going to cancel out on the right side. So I'm going to have f times r is equal to mv squared. Again, we're getting r by itself, so we're going to divide each side by f and get that r is equal to mv squared over f. For 11, they give us a is equal to 1/2 times b times h, and we're getting b by itself. So this is the same exact thing if you wanted to write it a different way, as a is equal to b times h, all divided by 2. So in order to get that 2 over to the other side, we're going to multiply each side by that 2. It cancels out on the right side, leaving us with 2a is equal to b times h. Again, we're getting b by itself, so we're going to divide each side by h. And we're left with b is equal to 2 times a, all divided by h. For 12, we have r is equal to k times l all over d squared, and we're getting l by itself. So again, I'm just going to rewrite this so that way I have a little bit more room. R is equal to k times l all over d squared. All right, so we want to get that d squared over on the other side, so we want to undo that division first. So again, we're going to get that d squared over to the other side by multiplying it on each side. Cancel out on the right side, so we have d squared times r, or vice versa, is equal to k times l. So again, we're getting l by itself, so we want to divide each side by that k. Oops, I want to do those. So that way l is equal to d squared times r all over k. Again, that whole idea is to get that variable that they're asking for by itself, so that way that equation is equal to that specific variable.